Hi, it's been a while since I last posted, but I wanted to share what's new with Arbgeom. If you're new to the channel, Arbgeom is a non-Euclidean marble game that I'm developing. Either way, I finally got rolling working by implementing the ND physics engine in this paper by the people behind 4D Toys, link in the description. And it doesn't only work in flat Euclidean space, but it works through curved space too. Although it is important to note that I don't really know if the rotational physics through curved geometry is exactly correct. I haven't seen anything obviously incorrect, so it's at least good enough for right now. And then going into another wormhole level, I've also improved the performance of dynamic manifolds and moving static objects. Here I've mapped Q and E to move the platform in a circular motion, T and G to control the radius of the wormhole, U and J to change the curvature through the wormhole, and I and K to change the distance between either wormhole. Doing this makes it easier to play around with various geometries, and also allows future level design to better incorporate the manifold into level. For example, you could have a wormhole be button activated, or you could allow the user to manipulate the geometry in order to complete a level. This is one example of what an actual level could look like for this game. The goal here would be to get the pink marble over to my side of the fence. And you can do that by going through the wormhole into this intermediate zone that the fence doesn't intersect, so you can cross over. From here you can just push the marble through. As you can see, right now it's a bit finicky to push the marble, but that should improve as I work on the movement systems in general. This is the same thing, but with a cuboid-shaped wormhole. I can go through to the other side of the fence in the same way. You could also put pressure on the player by putting the end of the level behind a closing wormhole, where you just need to make it through in time. Instead of a space-bending wormhole, you can have a portal that appears flat. This level uses a cutout in space that the marble can travel through to get into the other room. Like so. This is a more elegant version of the previous room, where the edges of the cutout are covered with boxes. This version of the level is essentially just demonstrating a worse way to implement impossible spaces. As you can see, the many boxes around the portal are slowing down the rendering significantly, although that can be improved for the future. Right now, the manifold is simply a loop. I can see myself and the other objects repeated several times as I travel down the loop. But if you add a half twist to the loop, then you get an extruded Mobius strip. Traveling through the strip, you can see that the pink marble starts on my right, then going forwards, it's now on my left, and then forwards, it's now on my right, and then left again, and so on. If I kick this marble, you can see that it's traveling both down the inner and outer edge of the tunnel at the same time, since for a Mobius strip, they're the same edge. I can then add another half twist. Traveling down the loop, the pink marble starts on my left, and then stays on my left as I continue to travel down the loop. Adding more twists leads to the manifold being essentially incomprehensible. You can't really see or fully understand what's going on when traveling through so many twists. This manifold is created from the rounded union of two hyperspheres. Right now I'm in one of the hyperspheres, and then I can cross into the other one. This creates an interesting effect where, here, from the gray region, it looks like the entire blue region is contained within it. But when I go back out, it looks like the entire gray region is contained within the blue region, even though neither of them are inside the other. If I kick this ball, you can watch it travel through the manifold and see that from here, you really can see the entirety of the gray region all at once. This and the following manifolds were suggested in the itch.io comments for this game. This manifold is one of the 40 versions of a torus called a tiger. The tiger has this weird feature where it has what looks like a central column, even though when you travel through it, you just loop back to where you started. If I kick this marble, you can actually see it in many places at once, since the light has many paths to take from the marble to you. Additionally, since the tiger loops around in XY space, what looks like the ceiling is actually another floor, which you can reach by jumping. Here, I have a tiger that is intersected with the XYZ hyperplane. I also have the fence separating either surface of intersection to show that the two sides are connected over the fence. I also have key binding set up for this manifold, so Q and E changes the XY major radius of the tiger, T and G changes the ZW major radius, and U and J changes the minor radius. Moving the surface into the wall like this allows you to see the wall while in the tiger, which makes it easier to navigate. This is a rounded sphere cone, or a sphone. Just like how a 3D cone has a circular base that extends out in a perpendicular direction, the sphone has a spherical base that extends out into the fourth dimension. Right now, I'm on the base of the sphone. You can see that the space appears to be mostly flat here. And then here is the tip of the sphone. Lastly, this is called a Duo-Spindle, and it has a couple of interesting features. It has this line running through the center of the manifold that effectively makes you see double, since light is curving around either side of the line and then coming back to the same object. This manifold also causes this weird effect where it looks like these two planes, the blue and the gray one, meet at an angle when they are in fact coplanar. So that's all I have for new manifolds right now, but I also want to show off the scripting languages behind everything. This is the Structured Scaffolding Language, or SSL for short. It's a custom language I made to build up 4D shapes to be used as manifolds or physics objects. The link to the repo for this language is available in the description, although it is very much a work in progress. Each class has its own fields and trait implementations. The projection function must be implemented for all manifolds and colliders. The SDF, or sign distance function, must be implemented for all rendered shapes. And the axis-aligned bounding box function must be implemented for all colliders. Most of these fields within each class are dynamic and can be changed during the game via scripting. This file just has simple shapes like 4D planes, spheres, boxes, and more. This file contains various operations like shifting a shape, inverting it, and intersecting two shapes. These classes have shape fields, whose trait implementations can then be used by the class like so. Finally, this file has combination classes that can be used to create new shapes out of other shapes. This is just for convenience, however, since you can still combine classes outside of these files. Once a shape is built up from a combination of classes, its trait implementations, for projection for example, get inlined into a single function. In Rust, that function is interpreted, but for rendering it is converted, then injected into the WGSL shader, where class fields get passed in at each frame through bind groups. To define worlds and levels within the game, I use RUNNNN, or Rusty Object Notation. Here I have the world defined with a few fields and a list of levels. Each level has its own parameters, including a manifold, a list of Rhai scripts that it should run, and the geometry within the level. The manifold parameter on the level and the shape parameter on the geometry reference the classes defined within SSL. Additionally, within these geometry definitions, you can write code which runs at each time step. This code is expressed within the expert blocks and is written in SSL. Finally, you have Rhai. Right now the scripting is pretty thin, but you can query for geometry using classes and IDs, and you can also have code executed on each key press. Anyway, thanks for watching. It'll likely be a while until I can publish the next beta to itch.io, so if there's a manifold or a feature you would like to see, leave it in the comments, and I'll see if I can add it in, or make a short video demonstrating it. Anyway, bye.